Hi, in this presentation, I will discuss the absolute convergence of iterative series, which is exercise 2.8.2. There are two theorems will be used. One is comparison test, which says that given two sequences A sub k and B sub k, and B sub k is greater than or equal to A sub k, then if the sum of the B sub k converges, then the sum of A sub k also converges. Another theorem is absolute convergence test, which says that if the sum of the absolute value of the A sub n converges, then the sum of the A sub n also converges by getting rid of the absolute sign. Now we can begin the exercise. The problem we have is that show that if the iterative series, the absolute value of the A sub ij, the sum of it is converges, then the iterated sum of the A sub ij also converges. We can find that the problem also gives us that, meaning that for each I in the natural number, the series, the sum of the absolute value of A sub ij converges to some real number B sub I. Then the series, the sum of the B sub I for I from 1 to infinity converges as well, which is two conditions that we will use in the following proof. Now we begin the proof. So by theorem 2.7.6, the absolute convergence test, we know that the sum of the absolute value of A sub ij for j from 1 to infinity converges to B sub I. Then by getting rid of the absolute value sign, the sum also converges to some C sub I as well. Then we have the following inequality. The absolute value of the sum is less than or equal to the sum of the absolute value. That's because A sub ij could be less than 0 or greater than 0. We have no idea. Since it is undetermined, when we first sum them together and do the absolute value, the positive value will counteract the negative value. So the absolute value of the sum will always less than or equal to the sum of the absolute value. Then we can know that this part corresponding to the C sub I, which is given here, and this part, which is converges to B sub I. And so we can get the following inequality. Then we can continue our proof. So since the absolute value of a C sub I and B sub I are consequence satisfying those inequality that was given by the previous slides, and the sum of the B sub I converges, then by the comparison test, we know that the sum of the absolute value of C sub I for I from 1 to infinity also converges. That is by the comparison test. And then by the absolute convergence test, again, we know that getting rid of the absolute value sign, the sum of the C sub I also converges. Now we can complete the proof. For each fixed I in natural number range, the series sum of the A sub ij for j from 1 to infinity converges to some real number C sub I, which is proven by the first step. As you can see here. And we also, by the proof that was given before, that the series, the sum of the C sub I for I from 1 to infinity converges as well, which is given by the previous proof that we have proved that the sum of the C sub I also converges. Then we can have the concluding that the iterative series, the iterative sum of A sub ij also converges. So that is the end of the proof. And thank you very much for watching my video.